Hello! You are watching Expressive Syntax. My name is Sam. This is the show, the YouTube channel, where we learn programming stuff together. Today we're doing more Ruby Koans. Let's see. So, last time we did arrays and hashes. Today we're on to strings and symbols. I hope you're excited. I'm excited. Let's jump right in. About strings. Yeah. I'm not totally in the wrong place. Give me a sec to get to the codes. There we go. And then I need to run rake. And hopefully we will be on this first one here. This double quoted strings are strings test. About strings line 6. Test double quoted strings are strings. Excellent. Okay. So is this big enough? Make it bigger just in case. Can't be too big, right? Okay, good. So double quoted strings are strings. So we have the string hello world, and we assert equal string is a string. This will be true because it is a string. We run it, and we're on to, where does it tell us the line number? Line 11, cool. Single quoted strings are also strings. Goodbye world. No, that's so sad. String is a string is also true. I'm feeling confident about that. I'm not even going to run the test. I feel so confident about that. Test use single quotes to create a string with double quotes. Okay. I'm going to make this a little bit smaller just so it all fits. Or actually, I can just close this menu over here. There we go. Boom. So here we have single quotes, and we're using double quotes inside the string. Assert equals, I guess they want us to just put this in here. Yeah. On to line 21. Cool. Test double quotes to create strings with single quotes. That makes sense. So if you want to type the word don't, it has a single quote here, so you need to use double quotes on the outside. I guess they want us to just put in this there. Yeah. Use backslash for those hard cases where we have both double quotes and single quotes. So, for example, he said don't. We have to use backslashes to escape the double quotes here. Or if we're using single quotes on the outside, we can use the double quotes on the inside, but we have to use the backspace to escape the single quote on the inside. Whew! All right, A equals B. Yeah, I think these are the same because when we escape the double quotes inside the double quotes, it's just like doing double quotes inside the single quotes, and vice versa. Like if we escape the single quote inside the single quote, it's like doing a single quote inside the double quotes. So, true. I have such a hard time spelling the word true. 34. Yeah, doing good. All right. Use flexible quoting to handle really hard cases. Oh my. So, flexible quotes can handle both single quote and double quote characters. So to make flexible quotes, we use this %sign parentheses syntax. Or we use the %sign exclamation point syntax, or alternatively, the %sign curly bracket syntax. So A is the same as B, that's true. It's just different ways of doing the same thing. and A equals C is true, and by the transitive property, B is equal to C. Let's see if I'm right about that. Let's run the rake test. 43. Yeah, okay, cool. Test flexible quotes can be handled flexible quotes can handle multiple lines. Yes. So we can use the %, curly bracket syntax again, and we can even put in multiple lines here. So long string dot length. I don't know. Does it actually want me to count the characters here? Kind of don't want to. But I will. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51. But it's not 51 because there are also new line characters. So it's 51 plus this new line character is 52 plus this new line character is 53 plus this new line character is 54. So that is my guess. 54. And lines.count, I think there's 1, 2, 3, 4? Maybe it's 3? Let's go with 4 and see what it says. Long string 0, 1. So this looks like what's it called? Slicing, like the way you would slice an array. We can slice a string by using a square bracket syntax. And I think this is saying that we start at the 0th line and get 1. So it's asking what the first line is, right? And the first line is just, or no, what's the first character? Yeah, what's the first character? And the first character is the new line character. And we represent that by doing this, I think. Do I need double quotes? Yeah. Okay. So I'm not sure about these 3 answers, but we'll learn something, whether I'm right or wrong. Yeah, okay. Expected 40 equal 3. So I guess the number of lines is 1, 2, 3, right? There's the first line, which is just the new line, right? It kind of skips down, and then 1, 0, 1, 2, 3. Okay, so I need to change this to 3. That makes sense. And then, did we get the other thing right? 53. Oh, whoa. Okay, yeah. So we're down to line 53. So okay, cool. So I was right about the number of characters, the string length, 54. It also counts the new line characters that we're not explicitly seeing here. The number of lines is equal to yeah, so here's how to think about it. The number of lines is equal to the number of new line characters. So there's one at the end of this line, and there's one at the end of this line, and there's one at the end of this line. So that's how you, it's like how many times would you have to press enter if you were writing this like in an email or something. 1 here, 1 here, 1 here. And the first character is n. I mean new line, not n, new line. Sweet. So we're on 53. Test here documents can also handle multiple lines. Here documents. Is that a thing? I think this, I'm gonna do some quick Googling. Well, Yeah, just because, yeah, I'm gonna do a quick Google. Oh man. Hello, Google. HereDoc. Yeah, this is something I've heard of before. HereDoc is a way of getting text input into a script without having to feed it in from a separate file. Okay, if you've got a small quantity of data you don't expect to change often, it's a quick and tidy way of keeping script and data together. Oh, guys, by the way, while we're on Google, have you seen this adorable thing? You can go to google.com and click on the image here, and it plays this adorable game. And it's about programming. Collect the carrots on the way using the code blocks. I spent like half an hour on this earlier. Yeah, so the code blocks start off pretty simple. Yep. But then eventually you get loops and other things. Anyway, check it out. It's super fun. It's a distraction, not what we're doing right now. But yeah, just play this game. It's really cute. Teaches you about programming. All right. I'll come back to, I'll do more of that later, maybe. Anyway, HereDoc, yes. So, a long string. It was the best of times, it was the worst of times. Excuse me. Assert equal long string dot length. So it wants to know the length of this thing. Oh, what did we figure out before? 54? I think it's 54. I don't see any reason why it would be not that. Lines that count? 3? First. This is different from a string though, isn't it? This is like a different kind of object? Am I right? Or is this? Well, let's see what it gives me. 53. Oh, what did I? So I put in 54. Expected 54 to equal 53. Oh, okay. So HereDocs, it doesn't start here. It starts here. So if I put in like that, it would be 54. But this this starting line is not where HereDoc starts. It starts on the following line, and then you end it with this. So 53. And that makes me think there's just 2 new lines here. There's one here and one here. And the first character is not the new line. It's actually that. So where are we? 60. Yeah, cool. Okay, cool. So we learned about HereDocs. You can put a bunch of big string in your code. Keep in mind that it starts on the line after you type this syntax. So the way you create a HereDoc is you use this arrow EOS. I wonder why it's EOS. I'm curious. Should we look that up? Why not? Ruby EOS. Oh, it's a cute little bird. I don't know. Let's see. Why? Yeah, that's what I want to know. Why is the inline string block in Ruby named EOS? What is the answer? EOS means end of string. It is displayed at the end of the string. Okay. But you can use other names too. Oh, okay. Interesting. So the thing that actually starts the HereDoc is this arrow and not the EOS. You could say any old thing. You could say end of doc as long as this is end of doc. Yeah. Oh, neat. Super neato. Yeah. Cool. All right. so HereDocs, arrow, arrow, and then the thing that ends the HereDoc. And it's like a marker that you're using for the end. And I guess the key is that this can appear anywhere inside of the HereDoc that you're creating, right? That's cool. All right. Test plus will concatenate two strings. Yeah, easy peasy. So string equals hello plus world. String is equal to hello world. Yep, 67. Plus concatenation will leave the original string unmodified. Okay, sure. So if we do hi equals the string hello, and there equals the string world, and then string equals hi plus there, it doesn't change what hi is. We're not actually adding there to hi. We're adding them together, and then the results of that expression, it's like there's no side effects, if that means anything. You know, it doesn't modify either. It just gives you the result. Anyway, so hi is still equal to hello. Boop. And there is still equal to world. Boop. Save and run the test. And yeah, 75. So plus equals will concatenate to the end of a string. Okay. So if you do want to modify hi, add something to it, you use plus equals. Yeah, and you can use plus equals. Yeah, if you're with any variable that you're adding something to, you can do this with numbers too, is what I'm saying. But we're doing it with strings, so hi plus equals there is hello world. I'm gonna copy and paste from above because I'm tired of typing hello world. All right, good. 83, yeah. Plus equals also will leave the original string unmodified. What? Okay, so we have original string hello, hi equals original string, there equals world, hi plus equal there, and it wants me to know what original, it wants to know what original string is at this point. So original string is hello, and this operation doesn't change original string, and this operation doesn't do anything with original string, nor does this operation do anything with original string. So therefore, we can conclude that original string is still hello. Yeah. The shovel operator will also append content to a string. The shovel operator, it's such a good word. I've always been the arrow, but it's the shovel operator. Cool, good to know. I like you know, it's fun to use something like all the time and then discover that it has a name. Oh, this is called the shovel operator. That's cool. We'll also append contents to a string. So hi there is like using plus equals. It adds there to the end of hi when we do hi shovel operator there. So hi will be equal to, once again, hello world, and there will be equal to just world, because the shovel operator doesn't modify the thing that we're shoveling in. World. Boop. 99. All right. Test the shovel operator modifies the original string. so that it is different every time. Every time I say that, oh, this is like this other thing, I'm totally wrong. There's always the next test will be about how they're different. Okay. The shovel operator modifies the original string. So they are similar, except the shovel operator modifies the original string. So when we do original string equals hello, and hi equals original string, and there equals world, and hi shovel operator there, it wants to know what original string is. Think about it. Ruby programmers tend to favor the shovel operator over the plus equals operator when building up strings. Why? So that you can chain them together, maybe? Something like that. Well, let's see if we can get this right. So this will be hello world. Yeah, okay, so it's hello world. Cool. Why is this a useful thing? If I'm doing hi there, how are you? Original string will equal hello world, how are you? So I'm testing whether or not you can kind of chain them together, right? Because that's my theory about why the shuffle operator might be more useful. Let's see. Does that do what I want? Yeah, okay, cool. Can I do that with plus equals is the question. Plus equals. Plus equals? No, I cannot. So that's why I think it's more useful, because you can kind of like put them one after the other with the shuffle operator in this kind of pleasant way. Yeah. If there's other reasons, let me know in the comments. Let me know in the chat. I'd love to hear your thoughts on this. Cool. Test double quoted string interpret escape characters. String equals new line. Assert equals string dot size is 1, because even though it looks like there's a character for the backslash and a character for the new line, they're actually sort of a combined meaning of like one character. This is the new line character. Single quoted string does not interpret escape characters. Yeah, okay. So string.size is actually 2 here because there's the slash and the n, and they're separate. You won't get a new line. Single quotes sometimes interpret escape characters. Wow, okay. So you can escape. What? You can use a triple backslash to escape a character? Is that? Okay. Interesting. Yeah, fascinating. So why? Interesting. Okay, so yeah, if you want to escape a single quote, you use the triple backslash. String.size is 1. Assert equal string. String is just the single quote. Yeah. 119. Oh, I got that wrong. 1 equal to 2. So why, okay. So we escape this backslash, so that's the first character, and then we escape the quote, and that's the second character? But then, okay. Testing single quote sometimes interpret escape characters. Okay. Curious, I'm just kind of playing around here because I'm, yeah, okay. So after I wish it was a little bit more clear about why this is it just that it escapes okay, I understand. Jeez, took me long enough. So I said at first you need the triple backslash to escape the single quote, the single quote. But I was wrong. It's not that you need the triple backslash inside the single quotes. It's just that with when you're inside the single quotes, you can still escape with just one backslash, the single quote, and with just one backslash, you can escape a backslash. But inside the single quotes, you can't escape new line characters. Is that clear? I hope that's clear. So what did we have here? We had, so this escapes this, and this escapes this. So we have 2 characters total. That makes sense. I hope it makes sense to you as well. Let me know if you have questions. I'll answer your questions if you leave them in the comments. Double-quoted strings interpolate variables. Yeah, string interpolation, super useful. You'll see this all the time. So you have a value, 1, 2, 3. The value is, and then you use this weird hashtag, curly bracket syntax to put in the value. And this gets kind of interpreted. The value, this variable gets evaluated, and the toString. So the way this works is that the toString method is called on whatever value is and stuck into the string. So here, oh, focus time. I hope that doesn't mess up my stream. I guess we'll see. We will see. So one second. I'm gonna check one thing real quick. Twitch. Am I still on? Am I still streaming? Uh-oh. I have this blocker for myself so I don't stay up past my bedtime. I think it's okay to stay up past my bedtime if I'm streaming. Normally I'd go to bed right now, but I'm making a special exception for, because I'm learning stuff, you know? That's where we're staying up a little bit late. Am I still online? Yeah, cool. Okay, cool. Closing that down now. So, where was I? The value is 1, 2, 3 because we interpolated it. Cool. I'm going to check that answer. About strings, line 120. Whoa, where are we? 120. Oh, I was not right about this. So what did I get wrong? You're going back a little bit. Ah, of course. After everything I learned, I failed to do that. So the reason we have to put a backslash here is because if we put in a backslash, it would escape the quote. So we need to put in a backslash to actually show the backslash. All right, let's see if that's happy. Sorry. Testing. 132. All right, good. We're good. Chugging along. Test single quoted strings do not interpolate. Ah, okay, yeah. So with a single quoted string, it'll just literally do this, and you won't see. It doesn't call toString on value. It just prints out this. So yeah, we're on to line 137. Test any Ruby expression may be interpolated. Ah, so you can put in any valid Ruby you can put in here, and it will evaluate it and then call toString and put that right in the string. So the square root of 5 is math.square root of 5. I feel dumb. What is the square root of 5? That, apparently. Okay, I don't feel so dumb anymore. I'm gonna just copy this. So break, yeah, 142. And line 142 is where we are. You can get a substring from a string. Ah, so the way that you can slice an array, you can also slice and split a string using the square bracket notation that we learned when we were doing stuff with arrays. So string is bacon, comma, lettuce and tomato, and we use this syntax to start at the 7th character and get 3 characters. So let's see where the 7th character is. This is, oh, and we're counting from 0. So 0, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. I guess the string is let. Let's try that. Let, or maybe it's ett. I'm not quite sure. But the idea is that we go 7 in and then get 3 letters after that. And here, it's the range notation. So we go from 7 to 9 inclusive. So I think it'll also be 7, 8, 9. Yeah. Let. 148. Cool. Cool. You can get a single character from a string. So bacon, lettuce, and tomato is once again the string, and we use the square bracket notation, and it's kind of like accessing elements in an array. You will get the string A because, again, we start counting at 0, and A is B is the 0th letter, A is the first letter. Right? 164. Yeah, sweet. Surprise? Not at all. Because we know programming languages start counting at 0. In older Ruby, single characters are represented by integers. What? Assert equal. What? In Ruby version 1.8. Oh, what? I'm on line 164. It must have detected my Ruby version and skipped ahead because I'm not on 1.8 anymore. I'm on some version of Ruby 2. Oh, interesting. So I can, oh geez, where did it go? I can forget about this test apparently. In Ruby version 1.9 and version 2, in modern Ruby, single characters are represented by strings. So, okay. So this is, what is this question mark syntax? I'm not sure what this is saying. Ruby question mark character. Indicates that a method returns a Boolean value. No, that's not what I want. I don't want the unary. Get an ASCII character. I think this is what we're talking about. So before Ruby 1.9 treated characters somewhat inconsistently. Being new to Ruby, I Googled it and found that question mark was the way to go. Question mark A. When I incorporate into my code, the result of that statement is the string A, no character code. Same issue with 0 and slice 0, both of which should theoretically return the ASCII code. I see. Okay, so then, okay. I wonder if there's a way to switch back to Ruby 1.8 to like try this out. So I think what this is saying is that the ASCII it gives you, when you try to find the value of a single character, it gives you the ASCII number. So this would be true, and this would be true. So in modern versions, it's represented by a character instead. So we get a string instead. And here we get A is obviously not equal to 97, so we get false. 172. Yeah, okay. So, okay, this used ASCII and this is uses strings. That's the lesson. And I like that. Strings, I mean, unless you're doing stuff with ASCII, strings are way easier to deal with. It makes more sense to me, I think. That's cool. Strings can be split. Sausage, egg, cheese, each word with a space in between. We do words equals string dot split, and then we get an array that contains sausage, and eggs, huevos, egg and queso. Oh, yes. Does that work? 178. Did I save it? Oh no, we're good. That was right. So test strings can be split with different patterns. So by default, if you call split, it splits on white space. But you can pass in what you want it to split on. If you want it to split on colons, put in colons. So this returns the rain in España, Spain. Patterns are formed from regular expressions. Ruby has a very powerful regular expression library. We will become enlightened about them soon. All right, cool. For now, it's enough to know that you can have other characters that you split on. You can split on any character. We could have split on A if we wanted to, and then it would have been an array containing this, and this, and this. Anyway, strings can be joined. So if we have an array with the strings now, and the string is, and the string the, and the string time, if we call join with the passing in space, it gives us a single string that combines all of those individual strings with spaces in between. So now is the time. Boop. 194. Yeah. Strings are unique objects. So this is maybe leading into the next topic a little bit, but remember this. Keep this in mind. Strings are unique objects. So A we set equal to a string, and B we set equal to a string, and it wants to know if A is equal to B. And even though these strings are identical, they are different objects, so they are not the same. So this is false. And for similar reason, because they are different objects, they have different IDs, that is false. Right? Wrong? 194. Expected false to be true. What? Strings are unique objects. Oh, wait, what? Assert equal. So, okay. Oh, they're equal because of course they're equal. A is equal to B, but they have different object IDs. They're equal because they're identical strings. And string doesn't just look at object ID to determine equality. It looks at the contents of the string. So A is equal to B, of course, but the object IDs are different. All right. Yeah, so now we're on to about symbols. Cool. I wanted to say, what did we learn? I wanted to say a couple more things about strings, I think. So, quick review. You can have double quoted strings or single quoted strings. They have somewhat different characteristics. It's good to know the differences. You can use string interpolation inside of double quotes, but not inside of single quotes. If you're forming long strings, you can use this percent sign syntax, or you can use this HereDoc syntax. Oh, one thing I'll say about interpolation. I'm not sure if this is still true, but I remember learning that because interpolation takes a little bit of time, even if you're not doing any interpolation. Because it's a possibility, double quotes are a little bit slower than single quotes. It has to check, are you doing interpolation? So if you can get away with it, it's usually better. Single quotes are usually preferred unless you need to use double quotes, or unless the style is like, oh, there's double quotes all over the place, so I'm just going to use double quotes. I could see it going either way. Like if I'm writing code for myself, I'll use single quotes, but if I'm writing in a code base that has double quotes for everything, I'll use double quotes. Anyway, that's about strings. Let's see what's next. About symbols. So about symbols. How long is this? It's not too bad. We're doing good. Symbols are symbols. Super cool. So we have symbols are denoted by this colon syntax. A symbol will always start with a colon. So we have a symbol, Ruby, and we say symbol is a symbol, and that is, of course, true. Like I say, I have trouble with the word true. Test symbols can be compared. Symbol 1 is a symbol. Symbol 2 is a symbol, and literally colon a symbol. And symbol 3 is something else. So symbol 1 equals symbol 2 is true. There we go. And symbol 1 equals symbol 3 is false. So run the test. Line 22. Yeah, we're doing good. So right, it looks at sort of the content of the symbol. These two symbols are the same because they're the same. But these two symbols are different because they're different. Identical symbols are a single internal object. Yeah, so this is one of the cool things about symbols. Symbol 1 equals a symbol. Symbol 2 equals a symbol. And we assert symbol 1 equals symbol 2. This is just like we saw before. This is true. But unlike strings, symbol 1.objectId is equal to symbol 2.objectId. So this is also true. Right? 28. Yeah. And so one thing that's neat about this is because they're internal objects, comparison of symbols is, because they're the same internal, like because they have the same object ID, comparing symbols is easier. So that's why symbols will be used as keys of hashes quite often, because it's very fast. Faster than it would be if you use strings for the keys of hashes or something. So if you can use symbols, it's generally speaking, for like internal coding purposes, better to use a symbol over a string, depending on what you're doing with it, because it's faster. Method names become symbols. Symbol as strings. Okay, so here we go. Symbol as strings equals symbol dot all symbols dot map x dot 2s. So we defined this method. Oh, this is a little bit meta here. We defined this method, and it gets added to the kind of global object symbol, and we call all symbols to get all of the symbols that we've defined. We turn all those symbols into strings, and then we ask Does symbols as strings include the string? Test method names become symbols. And the answer is true. So let's see, did we get that right? 41, yeah. So think about it. Why do we convert the list of symbols to strings and then compare against the string value rather than against symbols? Because so it's asking why we don't do this. Sometimes I need to figure out, like, actually see it to know. So this is like, instead of symbols as strings, we just have symbols. Does symbols include test method names become symbols? I don't know. Because I like asking you guys. Why is this better? Does this still work? 41. I mean, yeah. It seems to. Okay, I think I've been sitting here thinking about it, and I think I have an idea. Because okay, here's my idea. I'm gonna go back to, oh geez, do I still have it in my buffer? Yeah, okay. So here, I think the reason that we don't do this is because this is always going to be true no matter what we put here. Put a bunch of garbage, and this will still be true. Okay, so there's a clue. That's interesting. Yeah, okay, cool. So the reason is because as soon as we create this symbol, it gets added to, as soon as we this symbol gets added to symbol.allSymbols. So we want to avoid typing this symbol in our assertion. We need to have the string there. Oh, that's so cool. Yep. I'm glad they asked that question, and I'm glad I sat here and thought about it, because that's super interesting. Yeah. So obviously, we can't just put whatever we want here and make it pass, right? Because, yeah. unlike before with the symbol, all symbols get added to symbol.allSymbols. Even the ones that you put in your assert. So that's why. Neat. Tricky. In Ruby version MRI, I'm pretty sure I'm not on version, no, I am on version MRI. So online 41, yeah, okay. So Ruby Const equals, what is the sound of one hand clapping? Test constants become symbols. All symbols as strings. Interesting. Symbol.allSymbols.map2s, symbols as strings. We want to know if all symbols as strings includes okay, so here's some stuff. This is a constant because it's a variable that starts with a capital letter. That indicates that it's a special kind of variable that shouldn't change. And because we know that it shouldn't change, we want it to be an unchanging thing. And strings can change. You can use the shuffle operator to change them, for example. So it converts the string to a symbol. That's better because it's a constant and symbols can't change and constants can't change, so it's good. So I'm not sure quite how it converts it, so I'm going to look at what the test looks like. Or actually, I want to look at I'm going to do something a little bit cheatsy maybe, but I'm going to use puts to look at, will this give me the answer that I'm looking for? What is the sound of one hand clapping? Is this the thing that becomes a symbol? Or are they talking about they're talking about that. Am I making this way more complicated than it needs to be? All right, let's try that. 47. Oh, okay. I was making it way more complicated than it needs to be. I misinterpreted this completely. So this thing becomes a symbol. This is still a string. Yeah, okay. I was wrong. A little bit wrong. The way that methods become symbols, constants become symbols. The names of the constants become symbols. And this is still a string. Obviously. I must be tired. I'm confusing myself. Symbols can be made from strings. String is cats and dogs. String to sim. So this will be cats and dogs, right? Capital A. 53. Okay. Yeah, so you just call toSim to make something into a symbol, a string into a symbol. Symbols with spaces can be built. Whoa, what? That's neat. Cats and dogs. So you can still use the colon syntax to make a symbol. I thought symbols had to be without spaces, but if you do colon and then put it in quotes, it makes the quoted thing into a symbol, which is neat. Line 60. Cool. Symbols with interpolation can be built. Whoa, actually, this is cool. This makes sense because for metaprogramming purposes, that seems really useful. So this was cats and dogs. So we see interpolation just like we saw with strings, but can be used to make a symbol. And the fact that symbols are names of methods strikes me as like if you're dynamically generating method names, you can use this to make new methods, maybe. I don't know a lot about metaprogramming, but that seems to me like a thing you might do. 2s is called on interpolated symbols. So we have a symbol cats. We have the string. It is raining. With interpolation of the symbol and dogs. So just like we saw with numbers, it evaluates it and calls toString, and you can call toString on a symbol, so it becomes it's raining cats and dogs. I'm going to copy it because I don't want to type. Don't have to. Right? 72. Cool. Symbols are not strings. So we have a symbol, :Ruby, and it asks, is symbol dot is a string? And that is false. Symbol equals Ruby? I think this is also false. 78. Yeah, so it's not a string. So it's not equal to the string that, even though it contains the same characters, they are not equal. Symbols do not have string methods. Symbol equals not a string. So symbol dot respond to, sorry, I need to, symbols do not have string methods. Oh, I see what this is saying. So you have the symbol, not a string, and it's called that because it's a symbol, not a string. And you're asking, does it respond to each character? Which is a method on strings, but it's not a method on, on symbols. So this is false. And similarly, reverse is a method on string, but it's not a method on symbol. So that's false. Right? 88. Cool. It's important to realize that symbols are not immutable strings. Though they are immutable, none of the interesting string operations are available on symbols. Yeah, that's cool. Good. Yeah, true. Symbols cannot be concatenated. Exceptions will be pondered further down the path. All right. Assert, raise, no method error, I'm guessing. Let's see what it says. Yeah, no method error. For that. Test symbols can be dynamically created. So assert equal, we're doing cats plus dogs toSym. So we have the string cats and dogs and call toSym on it. It creates the the symbol cats, dogs. Think about it. Why is it not a good idea to dynamically create a lot of symbols? So, this because of the way they're stored differently in memory, maybe. Why is it not a good idea to dynamically create lots of symbols? So like meaning in a for loop creating 100 symbols, for example. my guess is that because, like we saw before, symbols get added to this symbol, global symbol thing, I think maybe garbage collection works differently for them. So like a string will get cleaned out of memory as soon as you're done with it, as soon as you change it. But if you dynamically create a bunch of strings, they'll maybe stick around when you don't need them to. That's my theory. Let me know if you have another theory or more ideas about why it might be a bad idea to dynamically create lots of strings. I mean symbols. I keep messing it up. Lots of symbols. So what do we learn? Symbols are not the same as strings. Symbols can be compared. Symbols are a single internal object. Method names become symbols. Yep. They can be made from strings and built from strings and interpolated. You can interpolate. Yeah, you can use interpolation to create a symbol. Anything else interesting about symbols? They're not. Yeah, you can't call each char reverse on them because they're not strings. Cool. Okay, so we learned the basics of symbols. We learned about strings too. This has been Expressive Syntax. My name is Sam. I hope you enjoyed watching. Let's see what we're going to do next time. So we did strings, we did symbols. Oh, next time we're going to learn about regular expressions, and maybe depending on how long it takes, we'll learn about methods too. Cool. Well, I'll see you next time. Bye.